Okay, so we're going to have a look at this Edco A question 5. This is a statistics question, so as I've been saying with some of the other questions, I think it's a good idea to get, maybe a green pen or a different color pen and just write the topic that the question is about on the page, so that when you're revising and you're looking to revise some statistics questions, you can stop on this question and go and have a look at what's being talked about. This is a question, very much a discussion question, where there is multiple different answers to the questions. The only questions where there's a definite answer are the questions later where they ask us about the range and where they ask us about the median, and we'll get to those in a minute. Before we actually go and have a look at the questions, we're just going to write down the types of data, and this is a nice thing to write down. If you have space, just in the margins or somewhere to write a little note, even somewhere in this box here, because all we're going to write in this box is the numbers 1, 2 and 3. So there's lots of space here to write this particular table that I'm going to draw. So types of data. We have two main types of data. The two main types of data we have are categorical, which is data that can be put into categories. So for example, the color of your car, the county you live in, things like that, they're called categories. Or we can divide it or split it into numerical data, which is obviously data that can be answered with a number. So the amount of TVs in your house, the amount of brothers and sisters you have. Those two sets of data can be subdivided. Categorical can be divided into nominal, where we won't be able to put the categories in a particular order. For example, the colors of cars, red, green, blue, there's no particular order to that. Or we can say ordinal, where we can put the data in some particular order. So if we went to a restaurant and I asked you what you thought of the meal, and it could be below average, it could be satisfactory, it could be excellent. They're categories, and we'd be able to put them in a reasonable order, an order that makes sense. Numerical data can be split into two categories, so we can have discrete data, or discrete numerical data, which is questions that can be answered with numbers, where we have a whole number answer. So how many brothers or sisters do you have? You would have 2 or 3 or 4, it would be a whole number. Continuous data is then data that is measured within an interval. So for example, if I asked you, what time did you run the 100 meters? You might say to me, you ran it in 10.2 seconds, but that's limited by our equipment as to how precise we can measure that. So continuous data is generally numerical data that has a decimal, but it can only be measured by the preciseness, let's say, of the equipment. It lies within a certain interval. So there are the four types of data. In this question, it doesn't ask us to be as specific as nominal, ordinal, discrete, or continuous, but it is good to know that the categories can be subdivided into those. Now, the answers that have been provided, I would kind of say that there's some discussion to be possibly had. So if we read the questions and then we place them either in categorical data or numerical data, and we can have a discussion as to whether we think those are the right categories or not. So first of all, please state your age in completed years and the month you were born. So they wrote down that this is 1 in numerical data. So they figured that this was a question that could be answered with a number. And indeed, your age in completed years can be answered by a number. But your month that you were born, that's a category. And so what I would do is I would split this question in two. I would split it into question 1A, which is your age in completed years, which is numerical. And then the month you were born in, I'm just going to put a B. And so I'm going to put 1B over this side. So the month you were born in is a category. It's not represented by a number, so the categories would be January, February, March, April, May, and so on. The second question is, what time did you get out of bed this morning? And again, there's debate as to whether this is categorical or numerical. I would say that this is numerical data. They wrote down that it was categorical data, probably, deciding that there was time intervals. So for example, you woke up between 7 and 7:30, and so that's more of a category. You woke up between those two times, 7:30 and 8. That's, again, a category of time, and we could put that in some ordinal, so that would be categorical ordinal. If we're being more precise and I ask you what time you got out of bed this morning, well then I would say that that's a number, and so I would put it in numerical data. So I'm going to get rid of it from here and I'm going to put it in numerical, though it's up for debate as to which it could go into. If it's split into intervals like this, 7 to 7:30, 7:30 to 8, maybe we could say it's categories. If we're deciding on a precise time we get up, so 7:29 and 14 seconds, well then we'd probably say that that's numerical data. Okay, the final one, there's no doubt about it. So what is your height? Your height is a number, so I'm going to put that in numerical data. So that goes in this column here, so that's number 3. And if we were deciding is that discrete or continuous, that would be continuous data. So your height isn't a whole number, or a natural number, let's say. It's a continuous number that lies between, within an interval, let's say. So you might say to me that you're 185 centimeters tall, but again, that's been measured by the preciseness of the equipment that you've used. So you might really be 185.213625 centimeters tall. Okay, so that's they're my answers to those questions. But again, if people had different answers, they could have had, for example, they could have put 1 as a numerical answer, 2 as a categorical answer, and then 3 is definitely numerical. And those were the answers provided. Let's go on to the next question and talk about, for each type of data, state the graphical representation which you would use to display the data collected. So what they're asking is, what are particular graphs that are suitable for numerical data and what are particular graphs suitable for categorical data. So let's write down categorical on the left here, and we'll decide on a few graph types. And then on the right hand side we have numerical. Now they only want a graphical representation for each of these types. For categorical, a good way to represent categorical data would be a pie chart, a bar chart, a line graph or a line plot. They're all good ways to represent categorical data. For example, if it was the month we were born, we could have a bar chart where we have our axis like this. The number of people would be on the side, and then we would have the months at the bottom. So we would have January, February, March, April, and then the heights of the bars would represent the number of people who were born in those particular months. And that would be a good way to represent the data. Likewise, if we had a pie chart and we were to divide it into the sectors, where we have January, February, March. Again, it's a good visual representation of how many people were born in each of the particular months. For numerical data, we would be better using a histogram, where we would have, again, 2 axes, would represent a range of heights. So for example, we could have our histogram that starts at 150 centimeters, and we could have 160, 170, 180, 190, 10 centimeter intervals, and then we could have the people who lie within those intervals. So for example, there might be 10 people who are between 150 and 160. We could have 12 people who are within 160 and 170. So a histogram is a good way to represent numerical data. Okay, so moving on, we are given a stem and leaf plot. Now this is called a back-to-back stem and leaf plot. So back to back. And a back-to-back stem and leaf plot is a good way to compare 2 sets of data. So just to go through the characteristics of a stem and leaf plot, we have the stem in the middle, which are the digits 0, 1, 2, 3, 4, all the way up to 8 in this example. And then the leaf is the portion then to the right of this for, let's say, Donica's party, and then obviously the leaf is to the left for Orla's party. And how do we read a stem and leaf plot? So generally we're given a key, so the key is down the bottom here, and our key says that 2 stroke 5, normally we have a little line in between it, that means 25 years. So if I have a look at Donica's party, for example, and I have 3, which is the stem, and then if I say 2 is a part of the leaf, 3 and then 2, that means that there was somebody at Donica's party who was 32 years of age. If I have 6 and 7, that means there was someone at Donica's party who was 67 years of age. If I go to Orla's party and I look at the 2, the stem, and then the 8, that means there was someone at Orla's party who was 28. And so that's how we read the stem and leaf plot. So one of the questions asked is, write one sentence to compare the distribution of ages of people at each party. Now the answer given in this question was that in Orla's party, the ages are between 27 and 41, which is correct. And then at Donica's party, there's two groups of people. One group from 0 years of age to 38, and one group from 45 to 84. And I suppose that is one way to compare the two sets of data. If I was comparing the two sets of data and looking at them, I would just say something as simple as Orla's guests are much closer in age to each other. So much closer in age. And then Donica's guests, or the people at Donica's party, guests have ages that are much more spread out. Much more spread out. So we're just looking to compare them. And so what I would say is, we can see at Orla's party, the ages of the people are very close together, between 27 and 41. And then at Donica's, we have kids at the party, 0, 1, 3, 8. Teenagers, 12, 13, 15. And then we have older people who are 83 and 84. So that's a comparison, let's say, between the ages of the people at the party. Now, on the right here, it says find the ranges of ages for each party. Now, this is the first bit of calculations that we're going to have to do. And so let's write down what the range is. The range of ages is the difference between the highest and the lowest. So it's the highest age minus the lowest age. So let's go to Orla's party and have a look. The highest age at Orla's party is 41, and the lowest age is 27, and so the range of ages at Orla's party is 14. And so the range is 14. Okay, what about Donica's party? So we've already said that at Donica's party they're much more spread out, and the range is a measure of spread. It measures how spread out things are. And so if we look at Donica's party, we have the oldest person is 84, so 84, minus the youngest person. The lowest age is actually 0, so we have a newborn, and so the range of ages is 84. Range is 84. And I would just write down in a different color pen on that question that the range is a measure of spread. Okay, so it's a measure of spread. And so we can see Donica's party, the ages are much more spread out than Orla's party. The next question asks us to find the median age for each party. So the median is the middle value. So we'll just write this down. The median is the middle value when the data is ranked. Now, ranked means when we order them from the lowest to the highest. And in a stem and leaf graph, the data is already ranked from the lowest to the highest. We can see at Orla's party, the lowest is 27 and the highest is 41. And it goes in order of age then. Same at Donica's party, the youngest is 0, then it goes 1, 3, 8, 12, 13, 15, in order all the way up to 84. Now, what's really nice about this question is that there is an odd number of people at Orla's party, and there is an even number of people at Donica's party. And the way we calculate the median is actually quite different for both of those. So let's see how we're going to go and do it. So to calculate the median, if there's an odd number, let's see how many are at Orla's party first of all. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 people at Orla's party. And so if we divide 9 by 2, we get 4.5. Now, there is an exact middle if you have an odd number of people. And to find that middle, we divide the number of people by 2. We got 4.5. And then we round that up to the next number. So we round to the 5th number. And when we do that, we can see that we have 1, 2, 3, 4. The 5th number is 33. And so the median age of guests at Orla's party is 33 years of age. Let's go and do the same thing for Donica's party, But in Donica's party, if we count the number of guests, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 people. Now, when there is an even number of people, there is not an exact middle. There's going to be 2 people who are in the middle. And so what we have to do is we divide 28 by 2 and we get 14. And then the median is going to be the average of the 14th and the 15th person. So we're going to add the 14th and the 15th and we're going to divide them by 2. So we have 0, or sorry, let's count them. So we have to go to the 14th person. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th is 34 and the 15th is 35, and we add them and divide it by 2 and we get 34.5. And so the median age at Donica's party is 34.5. Now, what's interesting is, even though there's a totally different range of guests between Orla's party and Donica's party, the median age is around the same. And that's where sometimes the measure of average, or the median, can be a little misleading. Yes, the middle person in each party is around the mid-30s, 33 and 34.5, but that doesn't actually tell us much about the range of ages of guests at the party. And that's why when we take a measure of spread together then with what the median is, which is a measure of central tendency, and we'll write that down, we need space, measure of central tendency. When we take those together, we get a better picture of what's going on. Okay, so finally, we want to make a suggestion as to what people were celebrating at each party. And there's multiple answers to this. There's no real right or wrong answers. So if we go to Orla's party, first of all, we have a lot of people in their 30s. And so what would people be celebrating who are in their 30s? We have from 27 up to 41. So it could be somebody who is announcing, that they're getting married. So perhaps it could be an engagement party, or something like that. Or maybe it's a birthday party of, a 34 or 35-year-old, and their friends range from 27 to 41. So I'd say an engagement party, possibly also a birthday party of somebody in their 30s, or somebody in that age group. Okay, what about Donica's party? What do we think they were celebrating? So Donica's party, well, here we have a range of guests from 0 up to 84. And so this could be a number of things. This could be a party for a newborn baby. So if it was a party for a newborn baby, that would explain the presence of the 0-year-olds. That's the newborn baby. And then, obviously you have their cousins, which are, young kids and teenagers. And then you have their aunts and uncles, which might be in the 30s and 40s. And then maybe the grandparents are in the 70s or 80s. Now, there's an awful lot of people at this party. And so, you could say that it's a celebration. It could be a grandparent's birthday either. It could be somebody who's in their 80s or somebody in their 70s who's having a birthday. So look, there's multiple answers to this. We could talk all day about the different possibilities of what these are. But Orla's party, the answers that were given, an engagement party perhaps, and then Donica's party, maybe the party of a newborn baby to celebrate that. Okay, so look, it's an interesting question. There's a lot of discussion in it. The only part of actual maths in the question was B part 2 and B part 3, and they're the only calculations, and then everything after that is open for a bit of discussion. Okay, good luck.